Okay guys, today let's talk about arrow pushing. During my time at Auburn, this topic was poorly explained, which made mechanisms very difficult to understand. It is simply the movement of two electrons at a time, and almost always represents a bond forming or breaking. You will want to remember your octet rule here. Let's work on a few examples and see if we can't further your understanding of arrow pushing. So in this first example, we're going to see a loss of a leaving group. Now there's a reason I've included the lone pairs around chlorine here, and that's just to kind of help you remember that with the octet rule, everything needs to have 8 electrons touching it, regardless of whether they're tied up in a lone pair or a covalent bond. So if I was to take a red arrow here and draw from the tail of the bond pointing up towards the chlorine atom, what this means is chlorine is going to peace out and leave this molecule, but it's going to take these two bonding electrons with it, okay? So we'll call this a loss of a leaving group, LLG, like so. And what that's going to do is that's going to leave carbon 2 devoid of a fourth bond. So it's going to have a secondary carbocation, and then somewhere floating around in space, I'm going to have chlorine with a full octet, and since it's in the 7 column, 7 minus 8 minus 1, formal charge. In this next example, we are going to see what we call a nucleophilic attack. So we're going to pretend like this spectator ion is not there. And what I have here is an O covalently bound to an H. 3 lone pairs, complete oxygen's octet, minus 1 formal charge. And we're going to draw the tail of an arrow coming from one of these lone pairs towards carbon 1. So that's now going to be too many bonds coming out of carbon 1 because, you know, carbon has 4 bonds. It can't have more than 4. That would violate its octet rule, so somebody's got to go. This chlorine is going to leave, so we're going to have another loss of a leaving group here. So we're going to draw the tail of the arrow coming from the bond, pointing towards the chlorine atom. And our final answer here is going to be our OH group, now bonded to carbon 1. We now have 2 lone pairs where there was 3. And then, yeah, again, somewhere floating off in space, I've got a chlorine with a full octet and a minus 1 formal charge. So notice here, I've got a bond forming between the oxygen and carbon 1. And here by this red arrow, I've got a bond breaking, specifically chlorine leaving carbon 1. On this page here, we're going to do a couple of resonance examples so you can kind of see, again, just how arrow pushing works and how it's just the formation, or excuse me, the movement of 2 electrons at a time. So if we were to take this pi bond here and flip it over just kind of like a windshield wiper, like so, well, I would end up with this molecule here. And notice the color coding of electrons so you can kind of keep track of what goes where. So now this pi bond exists between these 2 carbons. And then now this carbon over here is missing a 4th bond, so that's where our carbocation is now located. So anytime you do resonance, here we worked with a carbocation. You can also work with a lone pair. So if this lone pair were to kind of flip over, so I'm going to draw the tail coming from the lone pair pointing towards this bond right here. Well, so now that's going to be too many bonds coming out of this carbon here. So we're going to then have to take another red arrow, tail of it coming from the pi bond. So we're moving these 2 electrons, this orange and green one, and we're stacking them on top of this carbon here. And that's going to give us this molecule here. So notice this lone pair right here is now involved in this pi bond here. And the 2 electrons that's made up this pi bond here are now located on top of this carbon here. So in this example, the mechanism is called a proton transfer. And remember, proton is just another name for hydrogen. And so we're going to draw the tail of the arrow coming from a lone pair pointing towards this hydrogen atom. So again, here this is going to represent a bond forming. And in doing so, this alcohol is now going to form H3O+. If you found this video helpful, but you'd like to see more in-depth explanation and see a lot more practice problems worked out, you can find the full-length version of this video over at orgogoat.com. Please like, comment, and subscribe. Help our videos find more students like you, and tell a friend. And if you're interested in private tutoring, or if you want to see a concept explained that you don't see on our YouTube page yet, shoot me an email. or go yahoo.com.